Hi, everyone. This is Sebastian Traeger, Managing Director of Reliability Center, and we are back with another episode of Reliability 4.0. And as always, we're on a mission to help make the world a more reliable place. And today, we are joined by Todd Heindselman. We're thrilled to have you here, Todd. Thank you for joining us on the call.
Very excited, Sebastian. Looking forward to the conversation and helping everybody around the world.
Great. Well, you're with Liebherr. We see that in the background. Tell us a little bit about the company that you work for.
So I work specifically for the mining division, Liebherr Mining equipment. We build the ultra class mining trucks, the great big 400-ton dump trucks. We have 240-ton trucks as well that are out in service. And that's our little piece of the Liebherr world. We have mining excavators. We have, I'm sure some people have seen the construction equipment. We were started and really got known in 1949, 1950 for the crane division. But then we also, Liebherr has a hand in a little bit of everything. We do rail car equipment. There's landing gear for aircraft. We have home appliances, refrigerators, that sort of thing. So Liebherr kind of touches on a bunch of different places in the world.
Okay. Well, I love thinking about, dump trucks. Obviously, all of us when we were kids played with dump trucks. Mm-hmm. What do you think is your coolest piece of equipment as a company?
For me, it's the dump trucks. I had the opportunity to drive a couple of the trucks. So now I get to play with my own Tonka toys.
Okay.
It's kind of how I explain it to everybody because we get to deal with that 400-ton piece of gear when it's out in a mine somewhere.
Okay. That's incredible. So 400-ton, it will carry that much tonnage of rock or mineral or whatever.
Correct. So it's a 400-ton payload plus 240 some odd tons of truck and equipment. So 640, 650 tons of metal and dirt moving down a road. It's a pretty impressive sight to see.
So am I doing the math right? Is that over 1 million pounds?
Yeah, I think
we're testing our mental math. It's always dangerous when you have to do that really fast.
I did know I was going to have math questions today.
Right. That's good. Well, tell us a little bit about your background. So, obviously playing with trucks growing up was maybe interesting, but how did you end up in the maintenance and reliability world? How did that come about?
So I grew up in central Illinois, in Decatur, Illinois. And when I graduated high school, I joined the U.S. Navy as conventional machinist mate. So I worked on steam plants, turbines, and moved on to hydraulic equipment, air conditioning, elevators, all kinds of, the mechanical parts. And that was what I did for 6 years in the Navy. And after that, I learned how it works and decided, well, that was really pretty interesting, but now I want to know why it works. So I went to college and got a mechanical engineering degree, bachelor's of ME. So now I knew why it worked and how it worked, which kind of gave me, a different perspective on things. And then from there, I've done a couple of different jobs before I ended up with Liebherr in remanufacturing, where it was down digging into the nuts and bolts of the big components. And then from there, about 8 years ago, I joined the reliability group here. So it's a customer support reliability. So we're the customer facing side of it. And then I've just recently become supervisor of my group.
Great. It's great. Congratulations on that.
Thank you.
That's very interesting to learn about. I want to dive deeper into your work, especially given that you're customer facing. I think that'll be an interesting perspective. But before we dive into that, I always like to ask folks just something about you outside of work. What do you like to do outside of work?
Probably my biggest after work activity is I play ice hockey. I grew up in the upper Midwest playing hockey. We've got some pretty competitive leagues here in Virginia, a lot of transplants from up north and, because of the military presence in the area. So, I play pretty good. I play on a couple of different hockey teams, just free time. It's good stress relief, a little bit of exercise.
That's a fun activity. I would not think of kind of Southern Virginia playing ice hockey, but that's impressive. What position do you play? You look like a big guy. Are you a defender? Or
I'm a defenseman.
Okay.
I live and breathe in the back line with the power shots.
And are you allowed to drop the gloves or not so much in adult league?
Not so much in the adult league. We tend to think, more in the, I got to go to work tomorrow, so let's be smart about this. But there are occasions where it happens and, you handle business as you have to.
It's good. It's fun. Well, that sounds like a lot of fun to have a hobby like that. So, diving back into your work, and you mentioned you're on the customer facing side of reliability. What are the KPIs that you solve for? So, I'm used to talking to folks whose KPIs are uptime or things like that. But as customer facing, what are you focused on?
My biggest, probably most critical KPI is component reliability.
Hmm.
We do a lot of the Weibull studies, identifying trends, predictive life to provide the customer optimal lifetimes for component usage. When's the best time to exchange a component because of, it's a 400-ton truck. If something breaks in the middle of a pit, there's a lot of problems that are associated with that.
So, you're basically responding to customers who might be having problems, and then you all go in and say, well, what went wrong on this piece of equipment? Is that how you do it?
We do a lot of that. We also do a lot of predictive side. Since we're the OEM, it's kind of like with your vehicle, your personal vehicle. We're the OEM. So as after sales, we're very finely aware and attuned to how that downtime of the truck, how that component reliability affects and impacts our direct customers, which are the mines, the
Okay.
mines themselves moving dirt. So I look at, overall trends of how components are behaving, what sort of reliability we're expecting to see from them. And then we do also spend time if there's a problem. Yes, we come in, okay, let's get the data, let's understand what has happened and build that kind of that root cause case to say, here's where this all started and how we can prevent this in the future.
Okay. So, you'll go on site even and look at the equipment and investigate it if necessary.
Depending on the severity of the situation, yes. Either us or we do have our local affiliates, which are kind of our direct link between, the factory here in Virginia versus the mine site, whether it be in Indonesia or Australia or Chile or the US or, Zambia, wherever they happen to be. We have somebody there that can get on site and go look at the situation.
Okay. So, walk us through some of the key things that you're doing then, because I really want to understand this more from a customer facing side. Because again, a lot of the folks that we work with are effectively working for the company producing. You sound like you're a bridge between the end user and the design effectively or build of the units.
Yeah, exactly. We are that link between the user and the designer. So we'll take the design information and, there's the specified design life for a major component that, it should last however many thousands of hours. We'll get the information from the customer saying, hey, we take these off at such and such intervals. I have this many that fail. They fail at this many hours. They fail in these different ways. There's abuse, there's normal service, there's wear and tear, all of that factors into, and we'll do that investigation and say, well, based on the previous history and the improvements that are made in the design, we can say that these components we recommend, here's how to schedule your change out and how to do a planned downtime versus an unplanned,
Mm-hmm.
hit to the truck availability.
It's great. And in that role, what tools and technologies are you using to do your job? I always like to talk to folks about what practical technologies are they using, what tools are they using? What are you finding to be just an essential tool in your work?
Well, we have a couple of in-house solutions, Liebherr developed and Liebherr run programs that we use to track what we call the machine card data. So the when it's installed, when it's removed, condition it was found in, and that sort of thing. Obviously, there's a lot of time spent with Excel.
Okay.
Building the
Everybody's
data
friend.
tables, collecting the data and aggregating it, and then I'll take it. And depending on what I'm running, what I'm looking for, Prinska, we use their Weibull, what is it, HPK Prinska, Weibull plus plus software to
Okay.
do our Weibull charts. That's the primary one we use there. I spend time in Jump, which is an SAS product, to do data exploitation, data investigations, and kind of combine all of that, put it into various PowerPoint and presentative reports and that sort of thing so that we can get in and be able to not only take the raw data, but then do the analysis and the dive and presentation spend time with the fish bones, and be able to put that in a method and a presentation that the customer, the end user will be able to go, oh, okay, I see what you're talking about, and I see what
That's
happened.
good. That's great. So are there, I'm just again thinking about these mining trucks, are there sensors on them so that you're constantly able to understand what's happening with the machines and which conditions?
There are sensors. So we have two setups where we have just a phenomenal amount of data. And unfortunately I don't recall the exact amount, but it's a couple hundred channels. It's gigabytes worth of data that we get off of a truck. Some of that is remote accessible. I can right now go in and look at a truck that's running in Australia or
Huh.
running in Zambia and see conditions on that truck and a small history. But then we also have data that we can go to the truck and pull directly from the computer on it. That's a much deeper dive into that data. And we can really dig into the performance and what's happening down to, the second, the microsecond, depending on the system we're looking at, to analyze trends and go, this is where something occurred, and find that relation of how we got there.
Right. Well, that's amazing. I mean, that just that you have that much data, and given that you can see it across different locations and geographies and conditions, I'm sure there's all kinds. AI is obviously a buzzword now, and I'm thinking with that much data, presumably this is an area where you might be exploring what can AI do for you? What learnings can you have that you don't have to necessarily look for? Have you started to implement that, and what does that look like?
It's right now, it's an avenue that we're exploring. Mining traditionally is a little, I don't want to say reluctant, because that's not the right word for it. We're doing some amazing things with, trucks moving forward. But there's always that, let's make sure we really understand a new technology before we implement it across the fleet. So from the AI side, the artificial intelligence, we've started looking into it, but it's nothing that's widespread in use at this time by Liebherr.
Got it. Okay. Well, and I would think, obviously just with those types of machines, again, I have no idea what they cost, but I'm sure there's enough money in them that you, again, to your point, you want to be really certain if you're going to touch the knobs and dials that you're doing it correctly, because, any kind of miscalibration in it probably is a big deal.
And again, to the, you have a 650-ton piece of gear when it's fully loaded running down a haul road. The issue that you can run into is like with vibration monitoring. Am I seeing bumps in the road? Is it a rock that I hit that caused the motor to jump? Or did I really have some sort of vibration, just for an example?
Right.
So it's one of the difficulties in dealing with off-road mobile equipment. Is what you would normally do is, if I'm in the manufacturing plant, I can put vibration sensors and noise sensors and use that data to feed AI to say, yeah, when I see this, I know that's happening.
Right.
Now I have to account for that mobile.
And that's part of the challenge of AI, of course, is if you don't have a data set trained, then it doesn't really know what to look for. So our company, of course, helps people with root cause analysis. So I like to ask everybody that we talk to, how important are RCAs in your process?
Oh, they're critical. Absolutely critical, because you do have so many different applications, whether it's a flat coal mine, if I'm dealing with an iron ore mine that has really nice haul roads on it. I'm in South America where I'm at, 4,500 meter application where it's a very deep pit. And I have to take failures if they occur in all three of those instances and those locations, and try to determine, is it the same root cause? Is it a different root cause? Is it location? Is it application? There's so many ways that you have to drill down to the various failure modes to find the root cause, to see if it's a single point or are they related or not.
So then how frequently is, say, an RCA a part of your all's workflow? Is it a daily you have an RCA going on? Is it a once a month? How would you say in terms of frequency? Honestly,
kind of daily, because it depends on the projects that I'm working on. The RCAs can be sometimes it's a very structured event, depends on what I'm dealing with. Sometimes they're very structured. Sometimes it's a little more free. I don't want to say freewheeling, but it's a little more relaxed of we're doing the data analysis and we're doing the investigation, and it's not a, we're not following necessarily like an 8D for every problem.
Makes sense. Yeah. And if you can share, what's like one that you've worked on that's unusual or interesting where, some odd thing happened and you found
It's a good question. Well, we had one where we had ground fault problems, and it was very site specific and it was very time specific. And digging through the root cause, it was determined that where we initially thought it might have been a component, a piece part, it turns out that there was some salt introduced into the system during a shipment or something. I was like, okay, well, that is what was causing the faults, was dissolved and then dehydrated salt, salt that was pulled out of the water in a wash bay.
What was the theory behind the hypothesis as to why it was kind of at a very specific time? Because you said it was site specific and time specific.
It was only during periods of excessive amounts of rain.
Okay.
So it was only during, you could almost call it like a monsoon kind of rain.
Huh. So that was obviously pretty difficult to figure that one out, because you're like, what is going on here?
That one was quite an interesting, it was a lot of work, and it was a lot of, okay, gosh, how did we get here? And what's the solution? And it took quite a bit to dig into the root cause and figure out, okay, well, this is what's happening. The people that were on site managed to determine that, hey, look, we think this might be it.
It's great. It's neat. I love hearing it when it's like, well, we kind of found this edge case that, it shows exactly why it's helpful to keep going through that process. Todd, I always like to ask folks kind of one final word, and kind of by that, it's just think, you've obviously gained a ton of expertise in your job and in your, profession, and you've been doing it quite a while. If you could kind of go back and tell a younger Todd or somebody like you now for a piece of advice, what would that be? What's kind of something you want them to understand about being a reliability engineer that they might not?
Follow the data. Follow the data. Follow the data. Do not assume you know the root cause until you have some of the data. And I still catch myself doing it, going, oh, it's that? Yeah, it's because of. And then you spend 2 weeks in the data and you go, well, that's absolutely not it. I've had several times in my career across various industries where you think you know what the problem is and you think you know what the root cause is. And as you start the data, and I like to call it data exploitation, you're digging deeper and deeper into the data to really understand it. And at that point, you get down to going, oh, everybody thought it was, whatever the problem was over here. And in reality, I've got this piece is what's causing me the problem. So don't assume and follow the data.
That's good. That's great. That's great advice. And I feel like that's probably good for all walks of life, not just reliability engineering, right? Get some facts before you start assuming things, right?
Right. It tends to help.
So that's great. Well, Todd, it's been great talking to you. Thank you so much for being our guest. We've really appreciated it. And, I feel like we could sit here and talk a long time. I love hearing about the type of equipment you work on and the ways you do that. And so we just really appreciate it. Thank you for being on the show.
Absolutely, Sebastian. It's been my pleasure. I've enjoyed it. And you're right. I feel like we could sit and talk for a while about this and not cover the same ground twice, for sure. But really appreciate the opportunity. Thank you very much.
Yeah. And so to all of our listeners out here, again, Reliability 4.0 is really about helping engineers and really anybody think a little bit more about problem solving and about using practical applications for engineering and for solving problems. And of course, our company, reliability.com, specializes in RCA training and resources. If that's useful for you, please check that out. Also, if you're looking for a tool, you can use our software, easyrca.com. But in general, again, we're here just to work together to make the world a more reliable place. And we will see you on the next episode of Reliability 4.0. Thanks so much.
Thank you.